hardware for what it was intended for. And with that, we saw fast adoption, but we also saw fast resource consumption where the resources themselves got gobbled up really, really quickly. And so where we have been focused on is to create this sort of crawl, walk, run. And we've got a nice slide that sort of shows that a little bit later. But we want to give people the ability to develop locally and then take their code and push it up to the more enterprise grade software, either on a HGX or maybe they'll port it over to the cloud and like maybe Azure services. So that's sort of how we've approached this. So the Spark AI compatible PCs that have good GPUs on it affords us the ability to not put everything into the data center.
Right. And is most of your development work, is it done in-house? Are you guys looking at cloud, or is it a mixture? How's your workload for your researchers and developers partitioned out today?
We have a mixture. We have a really strong mixture. We have a strong strategic relationship with Microsoft, AWS, you guys with NVIDIA, right? So we try to lean in with everyone and allow our researchers to go where it makes sense for their project. So we do it all.
Yeah, it seems like that's the way these days. You can't get enough compute, so wherever you can find it and make it work for you. Yeah, I think that's the way it works. And so, well, maybe we could talk a little bit more about you guys have gotten some Spark systems in that house. How have you been able to integrate that into your workflow, and what's been your experience there? Maybe we can talk a little bit about that integration work that you've been doing lately with DGX Spark.
Chris, you want to take that question? I know you're hands-on with it.
Yes. Yeah. I would say at EPRI, we are definitely on a protracted journey with AI. What was kind of an eye-opening moment a few years ago when ChatGPT was released has really shown us and opened up a lot of ideas for different applications and use cases, especially for large language models. And so internally, we are kind of doing two approaches. We have the kind of the worker productivity angle, where we do want to be more productive and leverage AI tools, where it's appropriate and makes sense to help us be better at our jobs. But we also are looking at the applications of AI technologies to support our industry. So the electric utilities, the energy space, and there is some overlap. The research we do, the things that we discover and find, we can often work alongside our utility members and look at doing demonstrations and deployments. And the infrastructure piece of that is very important. Having hands-on access to GPUs, understanding, development environments versus production environments, how that might kind of dovetail with the data security, the governance, the privacy that our utility members are facing at their organizations. We're figuring that out here at EPRI as well, and we're able to share those learnings and go down that journey together with our members.
And do you find that, as your developers look at all these new technologies and learn, is it, what's been kind of the source of, everybody always asks me, how do I learn? How do I get started? Where do I go find out the latest AI technologies? Are you guys cultivating it in-house? Are there any particular sources that you would maybe want to share with people out there watching this, saying, hey, if you can do like us and you can learn from these sources? Anything you might want to share there?
I think the main, if you remember, like one thing, it's the Open Power AI Consortium, and that is a very large, over 200 member consortium that Matt spoke to. Did we put the link maybe in the chat?
Yeah, we can do that.
OPAI link, and you can go directly to it and check it out. But that, we have the three pillars in that, and I think that's really where we're going to get hands-on and looking at domain-specific models, use case integration, and then implementation. So with those three pillars, we are going to move forward together in our AI journey.
That's really cool. And, it sounds like you guys have been working with Spark for a little bit, and now you've got Spark kind of implemented and starting to integrate it into your workflow. I know you guys, maybe you can show us a little bit about what's going on there and some of the results you're seeing with Spark. I think you might have some more materials to show us to talk about that. If I want to go back to the slides there, Zach.
Yes. Yeah.
We can move around.
Maybe we could jump ahead to slide 5. Yes. Yeah. The when we get hands-on with AI technologies, we're very particular at understanding how these technologies work. Not just chasing a shiny object because it looks cool, but actually digging in and rolling up our sleeves and trying to understand what exactly is this doing for us? What's the value? Where does it fit? Maybe where does it doesn't fit? And the DGX Spark is one of those technologies. It is the GPU capability, the memory capacity that it provides. It opens up a lot of opportunity for us internally to enable our employees to have more hands-on experience with AI tools in a cost-effective way, while also maintaining the security, privacy, and compliance that we have to adhere to. So this slide is kind of a simplistic diagram of kind of the demonstration I'll show you today. But we have the DGX Spark, which is the gray box, and it has 120 gigabytes of memory, and that's the gigabytes with the little I there. 128 gigabytes if you do by 1000s. And we've loaded 2 models on it. The OpenAI's open weight model GPT OSS 120B. It's 120 billion parameters, and it was released back in August. And the whole model fits on the GPU, and we were able to use it at its full context length as well, the 131,000 token length that it supports, and then some. And when you put that entire thing on the Spark, you're using about 77 gigabytes of that 120 memory. So we have space left over. We can put on an embeddings model. The one we have on currently is Qwen 3 Embeddings 8B. It's another open weight model. This model, you don't really chat with it. You just send in text, and it gives you back a list of numbers. And that vector of numbers has a semantic meaning to it. And so if you're building a search engine or a retrieval augmented generation system, the vector database and all of these lists of numbers, arrays of numbers, are critical to making that happen. So this model, it can encode large chunks of text into these numbers very quickly, and so we use that to build up our internal vector databases that we can then use for search engines or incorporating into things like chatbots and other tools. So Qwen 3, the 8 billion parameter, it when it's fully loaded with the cache and everything allocated in memory, it uses about 17 gigabytes. So combined, we're around roughly 94 gigabytes. That leaves about 26 gigabytes of available memory for the rest of the DGX Spark, or maybe another small model that we may want to load onto it. Now, there's 2 groups of arrows here going into Spark. We have the top arrow, and I'll show you that first, the remote session. And that, if you're familiar with Linux, that's SSH into a Linux box, essentially. And then you can use terminal commands and so forth. However, a lot of our use cases need to go beyond the terminal. And we have a lot of data scientists, engineers, professionals who are not software developers. They're not necessarily AI engineers, but they understand their data. They understand their subject matter in the area that they're working in. and they may be familiar with Python or R or MATLAB. And so they have a little bit of coding experience. And what we're looking at doing at EPRI is enabling them to be more hands-on, more successful with these AI tools. So by loading up these models in a containerized fashion, you see the little packages there. Those are the containers. You can then connect your Python script to the model, or if you're writing code, you can do that. Or if you're developing software, you can do that as well. We also have kind of an internal interface. So if you have no coding experience, just a web browser, pull it up, and then you can start chatting with a model or interfacing with the model if you want to explore the embeddings, for example, or other things. You can get hands-on with it that way. So we try to accommodate a wide variety of our employees who are maybe AI curious, but not necessarily professional developers or AI engineers. And I guess I'll once again point out the importance of the pink dotted line all around this, which is closed environment. We have our legal counsel advises us on what we maybe should or shouldn't be doing with AI tools. Where's the information going? Is data leaving our closed environment? Our utility members are facing the exact same questions. So as we work through that and become more comfortable and proficient with that sort of policy framework at EPRI, we can speak with our utility members and help them navigate that as well.
Yeah, privacy is always an important topic these days, especially with AI. So important.
Okay, so I can share my screen and just do a very quick demo.
Yeah, why don't you show us what's going on there? We'll take a look.
Yeah,
at it.
it's we're keeping it simple just for time's sake, and just to want to show that we're connecting into this Spark device. And so I'm in that slide. I'm the guy at the top doing the remote session first, and it'll just take a look.
So while he shares the screen, I will say that the question you asked earlier, like what are we doing internally around sharing knowledge, Alan? We do have an AI leadership, quantum leadership team that we sit on, and we basically work together to create a center of excellence. So we have a SharePoint page internally that has been curated with knowledge of over 180, 200 different active participants in an AI experts team space that we feed information in that the broader company can pull from. So from prompt engineering, getting started with LLMs, getting started with using Jupyter notebooks, like we are able to, really pull in and get that knowledge sharing going. So
so you can
didn't
bring
want
them
to
all the
share
way
about
from
that.
entry level
Yeah.
through. That's great.
Yep.
Okay, so for those on the live stream that may not be familiar with command line or this terminal I'm showing you here, this is Visual Studio Code, and it's a integrated development environment, a code editor, if you will, provided by Microsoft. And it has an integrated terminal here, so I can make a secure connection into the DGX Spark. It's physically not with me at the moment. If you haven't noticed, it is in another city, but that is a excellent use case for us. We have teams all over the world, and the ability for us to kind of remote into these devices and like they were sitting on our desk is great. So we do have the mouse and keyboard connected, in where it actually is, but we can also remote into it anywhere in the world. So the terminal down at the bottom, I've already signed in. And so first we'll look at the NVIDIA SMI table here. I'll just close a few things. And you can see there's still some unsupported aspects with this particular version of CUDA. But if you look down at the bottom, you can see there are VLLM there's two instances. VLLM is an inference serving engine that can basically take a model think of a model as, a pile of numbers that kind of make sense in a neural network, and VLLM brings that to life. So it takes the pile of numbers and brings it to life, and it does it in a way that you can scale it up into a production environment. So the fact that we can run VLLM on a small device such as a DGX Spark helps us be more in alignment with the eventuality of something that we develop going into a production environment. The numbers here on the bottom, we have the 17 gigabytes. This is the Qwen 3 model, and then the 78 gigabytes for the GPT OSS 120B model. You can see right now we're idling. No one's using the box because I told people to stay off while I'm doing the live stream. So we're just idling at 11 watts, and then there's no utilization at the moment. So it's ready to go. Everything's loaded, and we can start using it. I do want to point out, I'll just show quickly our configuration. We're using Docker Compose, and the model, we give it a friendly name here. We're using the NVIDIA VLLM image 25.10 that was released a couple of weeks ago. This particular image of VLLM is compatible with DGX Spark. So it has the latest drivers, libraries. CUDA 13 is fully supported there. And so we're able to point to that and use that particular deployment of VLLM for Spark compatibility. We also have a few command arguments here. We specify how much memory we want to use. By default, VLLM will take up all your memory. So we just say, no, we only want you to use this much memory. And the magic number for DGX Spark with GPT OSS 120B is 64%. And you can kind of see a little bit of the math here. We have the model weights, some overhead with those is about 67, 68 gigabytes. We have to allocate a big chunk for the KV cache, which is the kind of intermediate caching of keys and values as the model is running. And that comes out to about 9 gigabytes for the full context length of this particular model that it supports. Noting that we could go higher if we had a lot of, multiple people using it at those lengths. So we add up those two numbers, and that comes out to about 64% of the 120 gigabytes. I will note it takes about 8 or 9 minutes to load the model, and that excludes downloading it, the first time. So if you're just like rebooting the Spark, and then everything's coming back up, you're going to add about 8 or 9 minutes just to get that whole thing loaded in memory and ready to go. And then just a quick peek down below, we have Qwen, the embeddings model, similar image from NVIDIA's VLLM 25.10. And we allocate a smaller amount of memory here because it's a smaller model, and the context length is a lot smaller as well because it's just encoding text into those arrays of numbers. So we do similar math here, and we came out with about 13% of that capacity. This one, being a smaller model, also has about 2 minutes of time to load when you restart the computer. Okay. So we have the, just for the remainder of the demo, I'll just run a query against the GPT OSS 120B. And if you note here that we're hosting on port 8001, and what that means, I guess, Alan, if you want to switch back to that slide again.
Yeah, come back to the slide, Zach.
Yeah. Yeah. So that circle where those 3 arrows are pointing, the web browser, the Python, and those 3 people on their laptops, that little white circle is port 8001 on this particular Spark. The Qwen embeddings, it lives on a different port number. It happens to be port 8000. And so if you wanted to interact with GPT OSS 120B, on this Spark device, you would address it on port 8001. So let me switch back to my screen. And what I'm showing now is, if you notice, I'm on localhost, so I'm hosting just a web front end, like a user interface, and it is pointing to that port 8001 on the Spark. So we have a very basic chat interface. So if you're not a Python coder or developer and you want to explore the model, then you have a very simple interface to work on that. We can fully customize it and work with the project team, the R&D team that's using it. And so it's a really nice pairing of bringing a developer alongside a subject matter expert at EPRI and gaining value and getting more hands-on together as a team. So we have our model choice here. It's DGX Spark. We have a serial number 00 here. So that's our early release unit. And we can, we have some other models here that are elsewhere, not on the Spark, but we can switch to those if we needed to. But I'll just show you the Spark for now. And let me just say hi. Hello, how can I help you today? So it's alive, it's responding. And let me put in a little more serious question here. One moment. So let's say I've loaded up some documents and I want to talk about the failure rate of wind turbines. So you can see the thinking model, GPT OSS, is a reasoning model. So it's on medium reasoning effort right now. And this is in real time, so you can kind of see the token rate as it's producing a response. We found that it's sufficient for development purposes. Now it's not intended to be a production box. So the speed at which it reads your prompt or your documents and then generates a response is very appropriate for testing and development purposes, maybe small teams like 1, 2, 3, 4 people. But it's not really suited for hundreds or
hundreds of people on your poor little Spark boxes. They kind of not what he was built for, and a little bit less.
Exactly right. So this one is still going. Sometimes it's kind of chatty, but that's okay. We can tame it with a system prompt. But I did want to point out here the output speed. We're seeing 34 tokens per second. And this thing, including the reasoning tokens, generated 2,000 tokens in about 56, 57 seconds. So
that token was pretty quick. Huh?
Yeah, it is pretty quick. Yeah. So that's, and so we did some testing, different levels of concurrency. So how many, users at the same time, what sort of throughput can we get out of the Spark box? And if you switch back to the next slide, you can see some of those results. And I think it's quite intriguing that we were able to kind of pull, a few hundred tokens per second out of the Spark box with some higher concurrency. So in the upper left corner, we have two models. We have a smaller GPT OSS 20B. Notice the 20, not the 120. That's the peach colored line. The green line is the model we just ran as a quick demo. That's the GPT OSS 120B. And me being a single user, you can see the 34, we were getting 34 tokens per second. And for some of our data scientists and researchers that do write Python and script things, oftentimes we'll write asynchronous functions or parallel functions where you can send multiple requests into the Spark box or the GPU at the same time. And this is where these things really start to flex their muscle. So if you send in 10 concurrent requests, you're going to get an aggregate throughput of about 100 tokens per second. on the output of the model for the 120 billion parameter model. And if you push in 100 concurrent requests, we measured over 400 tokens per second. For the size, the physical size, the price, the value, the scale of everything with the Spark box, that is very intriguing. And so the fact that we can set up almost like a little mock production environment, so to speak, but for development and testing purposes, adds a lot of value for us internally.
Great. And that, it's kind of what we built Spark for, is for developers, right? To be able to experiment their sandbox, they can test, they can develop. And we know a lot of people have big HGX clusters, and that's where they're going to deploy, but it gives them a place to work and experiment and get into the environment. So it's great. I was looking to see if there's any questions. I know we're kind of running out of time, but maybe someone asked about cluster deployments. Have you guys looked at maybe adding additional Sparks, combining two together? I don't know. I guess the general question is, what's next? What would you think if you're going to bring more Sparks into your environment? What would that look like, and where would you go?
Yeah, that's a great question, Alan. It is something that we've been looking at and working on. And, what I'm about to say is not supported configuration by NVIDIA, but here at EPRI, we do like to push the boundaries on what is the art of possibilities within the technology space. So most recently, we've been able to validate and test and connect a Spark to one of our Cisco 100 gig network core switches. And so we were able to bond two 100 gig ports to, give it 200 gigs, which would be the same as allocating it with a direct connect between two Sparks. The next phase of this approach is to actually scale and do a 1-to-1. So put another Spark onto the core, and then also see if we can go ahead and get past the theoretical limit of 2, which is having 3, 4, or 5 Sparks connected and communicating over the QSFP ports. We do know from our testing, and we've been very fortunate. EPRI was one of the first early adopters to start testing the Spark before it was ever launched to the public. And so we've had a jump start in leveraging these devices for some time. And our goal is to, yes, empower our users. And as we're working with bigger models like Chris and his fellow peers, we will have that capacity to do so. So we're excited about some of the testing we've got underway and in the works. But I will say that it's been hard. It's not easy because we're pioneers in this AI space with the Spark, and so we're learning just like everyone else in this community.
Great, thanks. One final question. I know we're kind of running out of time, but someone asked how many users on the Spark support before you start seeing speed drop. I don't know if you guys have done any testing there on. I'm assuming the number's not very high, but I don't know if you've done any testing there to see where it starts to bog down.
I think we got a funny story around that, more so around the collisions that can occur with having multiple users accessing a single box. And when we were doing some early on testing, we had users that were competing for loading and unloading different models, and we were beating the daylights out of the Spark. And the Spark got extremely hot, and to the point where you couldn't even touch the box. And so I always found that part of our research is to provide feedback to folks like NVIDIA or other manufacturers when we see things that are pushing too hard or too fast. And so one of the contributions I thought we made for the project was letting you guys know about the thermals, right? So saying, hey, this box, really exceeded some thresholds that we were expecting. Might want to put some additional code in to prevent the box from becoming, an issue for users in the workspaces. So yeah, I would say if you're all working on the same model, probably okay. But we've had up to what, Chris, 5, 6 people at once logged into the box interacting with it.
Right.
Didn't see any issues.
Right.
Yeah.
And we definitely appreciate EPRI helping us out early on. As Matt mentioned, we sent out a few systems early. We want to get some hands-on use and valuable feedback to help us get the product ready before the first customer ships went out. So again, thank you for that. And I think we're about out of time. I know lots of people request. We did put links to the EPRI websites, and we'll gather up the questions, and we also respond back after. So thanks, Zach, for putting that up. So again, I'd like to thank you guys for coming on today and letting us know what EPRI's up to and how Spark has been working out for you. So thanks again, Matt. Thanks again, Chris. And also, again, thanks to Zach, who's behind the scenes. He always keeps us running and keeps the tight ship going. So thanks, Zach. And thanks to all of you for joining us today. And I saw a few new Spark owners came on. People just got their Sparks in. So hopefully, you have some interesting times ahead of you with your Spark and development. Again, we put lots of resources and links for you too to help you get started. So thanks again for joining us, everyone, today, and we'll see you again next week. Thanks.
Thank
Thank
you.
you.